zeros of polynomials with real coefficients. Now, take a look at this theorem. If a polynomial with real coefficients has a plus bi as a root, its conjugate pair, a minus bi, is also a root, and this is true for all polynomials with real coefficients. So let's take a look at this example problem here. Find the values of a and b, where a and b are both real numbers. If 1 minus 4i is a root of the polynomial, z to the 3 minus 4z squared plus az minus b equals to 0. So, first of all, let's use the information that a conjugate pair is also another root. So, if we have 1 minus 4i as a root, the other root has to be 1 plus 4i. And now, if you take a look at this polynomial, we see that it is in the power of 3, so there has to be 3 roots. And if we found 2 of the roots already, I'm going to let the other root equal to r. So I'll say let r be the third root. Now, let's take a look at this polynomial. And our goal here is to find the values of a and b. Now, what we're going to do here is actually just first find out the value of r really quickly. And we can do this using Vieta's formula. We can say the sum of all roots is going to be equal to the negative 4 divided by positive 1. So the sum of roots is going to be the negative of negative 4 over 1. So that's really just 4. And let me simplify the left part. It is going to be 2 plus r equals to 4. So r equals to 2. That is the third root. Now, let's find a and b, also using Vieta's formula. So I can imagine finding b is going to be quite easy. B minus over 1 equals to the product of all roots. So there's going to be 1 minus 4i times 1 plus 4i times 2. And this is going to be b equals to 1 negative 16i squared times 2. And I squared is negative 1, as discussed in the last video. So, it seems to me that b is going to be equal to 34. And now let's find out a. A over 1 is going to be equal to 2 times 1 plus 4i plus 2 times 1 minus 4i plus 1 plus 4i times 1 minus 4i. So there's going to be a equals to 2 plus 8i plus 2 minus 8i, and this is going to be plus 17. So a equals to 21. And there you have it. A equals to 21 and b equals to 34. The most important part of this video is going to be the fact that conjugate pairs come in pairs as roots of a polynomial.